Hello everyone, this is Mr. Kissinger, and today we are doing 5th grade math module 3 lesson 2. We're going to make equivalent fractions with sums of fractions with like denominators. So we're going to kind of expand on our equivalent fraction lesson that we were doing last time, lesson 1. We're going to use number lines this time as opposed to a visual model to help us understand equivalent fractions and adding fractions a little bit as well. So this number 1 says show each expression on a number line and solve. So I'm going to draw a number line under letter A here, and we'll start right at the beginning. Now this number line, I'm going to use fifths. First, I'll start by just doing some hashes here. I'm going to fill those in as we go. Probably don't need this many, but we'll add a couple extra just to be safe. So this right here is going to be 0, 0 fifths. This is 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths, which is 1. Put in parentheses here, 0, 1, and then 6 fifths and 7 fifths. Those are numbers larger than 1, greater than 1. So I need to add 2 fifths plus 1 fifth. So to get to 2 fifths from 0, I'm going to skip over here to 1, 2, 2 fifths. And then I need to add another 1 fifth. So I'm going 1 more fifth up my number line. And where am I? At 3 fifths. We're going to continue to do this on the number line, but notice that our numerator changed, our denominators stayed the same. Fifths is the unit that we are using when we're adding, so that will remain the same. Let's look at letter B. This time, we're using thirds. So we have 0 thirds, which is 0, 1 third, 2 thirds, 3 thirds, which is 1, and then we'll go to 4 thirds, in case we need to go to 4 thirds. We have 1 third here, plus 1 third, plus 1 third. We're right here at 3 thirds, or 1. So if we add all of these together, well, we have 1 plus 1 plus 1 is 3 thirds. Now, 1 third plus 1 third plus 1 third, we can also express as 3 times 1 third. because if we add 3 plus 3 plus 3, or 1 plus 1 plus 1, well, 1 plus 1 plus 1 would be 1 times 3. 3 times 3 times 3 would be 3 times 3. So we're gonna see that down here. So I'm gonna move along to this letter D right here. It says 2 times 3/4 plus 1/4. So I'm gonna make my number line first here. There we go. 1, 2, 3. That'll be enough. All right. So we have 0/4, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and 7/4. So if I have 2 times 3/4, I have 1, 2, 3, or 1, 2, 3 to 3/4. Then I have to go 1, 2, 3. So I've gone 3/4 2 times. 2 times 3/4. 2 times 3/4 is the same as 3/4 plus 3/4. Two groups of 3/4. And then we need to add one more fourth. So I'm going to add one more fourth, plus 1/4. We fall right here on our number line at 7/4. And if we add our numerators together, we see that we get 3 plus 3 plus 1 is 7. And we keep our denominator the same. Our denominator doesn't change when we add fractions with the same denominators. 7/4. So we're going to kind of do what we were just doing, except we're going to deconstruct it. We're going to do it backwards. So it says express each fraction as the sum of 2 or 3 equal fractional parts. Rewrite each as a multiplication equation. Show part A on a number line. So instead of 6/7, we're going to break 6/7 up into 2 or 3 equal parts. I'm going to break it up into 3 equal parts in this case. I'm going to do 2/7 plus 2/7 plus 2/7. 2 plus 2 plus 2 is 6, and my denominator stays the same. So I have 2/7 plus 2/7 plus 2/7, and that will give me 6/7. But instead of writing it as 2/7 plus 2/7 plus 2/7, if I have 3 groups of 2/7, how else can I express that? Well, I could say 3 times 2/7, because I have 2/7, 1, 2, 3 times. I'm going to draw down a number line here. So 1, 2, 3, 4, 5, 6, 0/7, 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7, and I could have 2/7 plus 2/7 plus 2/7. I get 6/7, or 3 times 2/7. 2/7 3 times, and that gives me 6/7. So taking that a step further, This number 3 says express each of the following as a sum of a whole number and a fraction. Show parts C and D on number lines. So we'll just do A and C. A is 9/7. If I want to get a whole number in sevenths, how many sevenths is one whole? Well, 7/7 is one whole. 7/7 plus what will give me 9/7? Well, 9 minus 7 is 2. So I know that 7 plus 2 would equal 9. So 7/7 plus 2/7 equals 9/7. I can also write that as 7/7 is 1 whole plus 2/7 equals 9/7. 1 plus 2/7 could also be 1 and 2/7. 1 and 2/7 is 9/7. Those numbers are equivalent. Now we're going to do C, but I'm going to show it on a number line. So we have 32/7. Let me draw my number line first here. I'm actually going to draw it on the bottom so I have a little bit more room. Because I'm going to need 32 of these. All right. So I have myself a really long number line here. And each one of these is a seventh. So I have 0, 1, 2, 3, 4, 5, 6, 7 is 7/7, which is 1. 1, 2, 3, 4, 5, 6, 7. This is 2, which would be 14/7. 7 plus 7 is 14. 1, 2, 3, 4, 5, 6, 7 is 21/7, which is 3. I'm going to skip counting by sevens for my numerators. 3 times 7 is 21. 1, 2, 3, 4, 5, 6, 7 is 28/7, which is 4. 1, 2, 3, 4. So this is 32/7, which is where we need to be. So if I go by ones, so I want to show a whole number and a fraction. So I'm going to count by whole numbers first. I have 1 to 7/7, 2 to 14/7, 3 to 21/7, 4 to 28/7. And then how many sevens do I have left? 1, 2, 3, 4 sevens. So I have 1, 2, 3, 4, and 1/7. I guess I should just do ones here. It'll be 4 altogether. but I want to count my jumps, how much I'm jumping by. 1, 1, so 1 plus 1 plus 1 plus 1 plus 1/7 plus 1/7 plus 1/7 plus 1/7. I have little tiny plus signs in there. Equals, well, I have 1, 2, 3, 4, and 1, 2, 3, 4/7. So I have 4 plus 4/7 altogether. So I'm just I'm counting by sevens until I get the closest number I can to 32, which was 28. And then if I kept going on my number line, the next number I would reach is 35 by sevens. 33, 34, 35. So I'd have 35/7 would be the next one. And that would be 5. So 32/7 would fall right between 4 and 5. So it's not quite 5, it's 4 and 4/7. So that's all the time we have for today. We're going to kind of continue with working with fractions and equivalent fractions in the next lesson. Thank you guys so much for tuning in, and look forward to seeing you next time.